Okay. So in this syntax, to declare a structure, struct is a keyword. Structure name is an identifier. See, whenever you come across the term identifier, you have to remember the identifier rules. Then only you can write the identifier. So generally, I see students will byhead the variables in programs. Okay, these many variables comes in this program, and these are the variable names in this program. So don't do that. Okay, if you remember that that is an identifier, just remember the identifier rules and write on your own variables. Okay. Struct is a keyword, structure name is an identifier. Type can be any basic type such as int, float, char or double or derived types. So in the format we have right type. Type is a data type. So this data type can be int, float, char or double or derived data type. The member 1 to member n. So here n is missing. Member 1 to member n are the names of the or the members of a structure. So here actually they will call by variables also. But for us to understand, let us not worry about the variable name for members, because maybe for us it will feel confusion. Okay, let us call members only members, because there is one more concept called as structure variable. Okay, so here we will call it as a members of a structure, that is member 1 to n are called as members of a structure. So these member names, instead of variable you call it as member, these member names should be valid identifiers. So what all the things comes in identifier, and what are the keywords, and what are the data types, you have to remember in every syntax, not only in structure, in case of every syntax. Okay, here struct is a keyword, structure name and member names are the identifiers. So you have to remember the identifier rules and write it. Then type is nothing but data type. Okay, so in case of data type also, int, float, chr, double, these are all again keywords. Okay, next thing, so examples of variables, that is identifiers which store single. So here what I have done, when we write a variable without the array concept, with array concept and with structure concept, so what are the things happens at the memory level, we will see it. Okay, so before that you just take this screenshot, definition and syntax with explanation. Okay, fine. so so here we will compare the things like, uh, take variable which stores single value. So take a variable which stores more values with the same type, and take the variable which stores more values with same or different type. So examples of variables, that is identifiers which stores single value. So here declaration or definition statement. See here I have declared 5 variables a b c d e of type integer. So in this way also we can declare, that is separately, or in one line also we can say int a comma b comma c comma d comma e. So when we declare these variables, you look at the memory representation. In each variable I can store only one value, so not more than one value. So that is the case of values, variables which store one value, single value. So you look at the memory representation, in a b c d and e I can store only one value. Okay, just I have indicated by one box. When you come to an array, example of an array identifier which can store one or more values. Okay, but data type should be same. So let us consider array which can store integer values. So you look at the memory representation. Okay, a of 5. So 5 is the size I have taken. So maximum 5 values you can store. Less than that or equals to that you can store. Okay. You look at the memory representation. So 5 values part I have given here. Values. It is the values part. You can store 5 values. And the index. Index means each value is indicated by this position. So position 0, 1, 2, 3, 4. So in case of arrays, position starts from 0, ends at n minus 1. That is 5 minus 1. That is nothing but here 5 minus 1 is 4. Okay. So this is the array concept. So the above array A can store 5 values. The values 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. That's all. Not 5 here. Only 4 up to 4 are subscript or index values. So this is in case of arrays. When comes to the structure, you see here I am storing more values with same or different type. In case of arrays, I am storing all the 5 values which belongs to integer type only. But in case of structure, you see struct student. In this case, say roll number and marks are integer type, name is a character type, percentage is a float type. That means I can store same data type values or different data type values. That is the advantage of structure. So both array and structure are called as collection only. In case of arrays, only one type values you have to store. In case of structure, you can store one or more types. Okay. In the above example, struct is a keyword. Just you compare this example with syntax, whether it matches or not. Structure name is a student, type int, character we have taken, int character float data type we have taken, members, roll number, name, marks we have taken. We just compare here. Okay. So in the above example, struct is a keyword. The identifier student is a structure name. Okay. The variables, or we can say members of a structure. The members, roll number, name, marks, and percentage or the members of a structure. The members of a structure should be valid identifiers. Okay. Now this statement is very important. So you just compare with the variables which store single value, arrays, and structure. In the other two cases, that is variables which store single value and array, I have written memory representation. You just observe here, memory representation of variables which store single value, memory representation of arrays I have written. But in case of structure, I have not written memory representation. There is a reason here. I will tell you. I have not written memory representation. Okay, for roll number, name, marks, and percentage, because we look at the last sentence. When the above code is executed, no memory is allocated for variables, or we can say members, for members of a structure, that is roll number, name, marks, and percentage. Okay. When the above code is executed, no memory is allocated. That means computer will not give any memory for this. If it doesn't give any memory, then we cannot store value, because we can store values in members only we have memory. So generally in real world also, if there is a space, we can keep the item. If there is no space, how can you keep the item? Similarly here also, if there is a space, memory space, you can store the value. Otherwise we cannot store the value. So with this declaration, when I stop the declaration with semicolon, so this is called a structure declaration. If I stop at this point, that means if I write only this much code, I cannot get the memory. So something extra to be added. So that extra thing is nothing but structure variable. So only we can call these things are structure members. And one more concept we have, structure variable. So I think time of still 2-3 minutes is there. It will take time, some 10-15 minutes it will take, so that we shall stop today. Okay. So people take the screenshot of this. So tomorrow we will continue. So only 2 minutes is there. Okay.